Welcome to the channel. So in this second video of manufacturing engineering, we are going to discuss about oxy-acetylene welding. In the first video we already discussed about the types of welding process. In gas welding process, what happens? A gas is used to create a flame. That flame generates the required heat to melt the metal, and using a filler rod of the same metal of the metals which we are joining, that is applied to the joint which is required. Okay, and through the nozzle, through the burner, mixture of acetylene and oxygen is sent to get the flame, and that flame is of different types depending upon the amount of oxygen and acetylene present in that fuel. Okay, if the oxygen acetylene is in same amount, then it is called neutral flame. Then if the oxygen is more, it is called oxidizing flame. If oxygen is less than acetylene, it is called carburizing flame, or carburizing or reducing flame. So the three types of flames that we are going to discuss. Okay, so basically gas is used, and the first that is we are discussing in this video is about oxygen and acetylene mixture. This is the most common type of welding process, gas welding process. That is, another one type is oxygen hydrogen process, but oxygen hydrogen is a older method compared to oxy-acetylene, which is not very efficient compared to oxy-acetylene welding. So mostly this is used, and there is exothermic reaction between oxygen and acetylene. Acetylene is burned with the help of oxygen. The heat content generated is 55 megajoule per cubic meter, as you can see. Okay, these temperatures we are going to discuss in the next slide. So there are three types of flames, as I told you already. The first one is neutral flame, then there are carburizing flame and oxidizing flame. So what happens in the first, say in the neutral flame, the amount of oxygen and acetylene is same. It is taken in 1:1 ratio. So first what happens? There are two reactions mainly. First, carbon monoxide is generated. Carbon monoxide is generated from the acetylene burning, and because of which a small inner white cone is formed. Okay, as you can see in the figure, there is a inner white cone of small size, which is having a temperature of around 3100 degrees centigrade. Alright, so here carbon monoxide is formed. As also we know that atmospheric carbon monoxide present, then that will react with atmospheric oxygen to form carbon dioxide again. Okay, in the second reaction, carbon dioxide is formed, and this reaction also generates a lot of heat, but because of the area is larger. Now say this acetylene is burned from the at the tip of the burner, and that's why the cone, small cone is formed. But in case of the second reaction, though the heat is generated is equal or more than the first reaction, but because of the larger area of spread of the flame, the temperature is less than the inner white cone, that which is around 1275 degrees centigrade. So this flame is because of the formation of carbon dioxide while burning of carbon monoxide and acetylene. And this color of this outer flame is blue. Okay, generally this is our required inner white cone, which will generate the required heat to melt the metal. And this is most desirable type of flame. Generally, if there are no disadvantages regarding the metals to be joined or any special metals to be joined, otherwise this flame is normally used. Okay, carbon monoxide and carbon dioxide, because of burning formation of carbon monoxide, this inner white cone will be formed, and because of the second reaction which will create carbon dioxide, this region is formed. This is of blue color, of temperature around 1200 degrees centigrade. Then in case of carburizing flame, as I told you already, the acetylene amount will be more than oxygen. In this case, oxygen will be less compared to acetylene, and because of which the temperature will be less than the neutral flame as well as oxidizing flame. In this case, as you can see, this is the inner white cone, which is formed because of the carbon monoxide formation, which will give us a temperature of around 2900 degrees centigrade. In the first case, it was around 3100. In this case, it is around 2900. The outer flame will be of having same temperature of around 1275 degrees centigrade, which is because of the formation of carbon dioxide. Now, this new thing is that the intermediate flame feeder. Okay, this intermediate flame feeder of reddish color is because of the excess amount of acetylene present in the flame. Okay, as I told you, oxygen is less, so acetylene will be more. If there are excess acetylene, then that will burn, creating a intermediate flame feeder. and this is not desirable. Okay, this should be as less as possible for to generate more amount of heat. And this type of flames are used in case of metals which are readily oxidized. Okay, like oxygen free copper alloy is one of the examples of the metals where we have to apply carburizing flame to metals which are readily oxidized. Okay, so in that case we have to use carburizing flame, otherwise we can go for neutral flame. Okay, so the amount of heat generated will be less compared to neutral and carburizing flame. There will be intermediate flame feeder. Also in some cases, especially in gas cutting process that we will discuss in some other video, what happens if we release only acetylene and burn only acetylene without giving the required oxygen from the cylinder, then what happens, acetylene takes oxygen from the surroundings and burn, creating a carburizing flame. Okay, so initially if we don't apply oxygen, only acetylene is burned, then that will always give us carburizing flame. Then the third type and is called oxidizing flame. So in this case obviously the oxygen is more compared to acetylene. So if oxygen is more, then burning will be more, the temperature will be more, heat generated will be more, and the temperature is around 3300 degrees centigrade in the inner white cone. Okay, the temperature is obviously more compared to both neutral flame as well as carburizing flame. Here oxygen is more. Also because of the rapid burning and high burning, there will be noises will be created and sparks will be generated. Okay, because of the generation of sparks in the metal, there will be burning, and so there will be noise creation. Okay, and like firecracker burning sounds, that type of sound will be created while using oxidizing flame. So oxidizing flame is also not used compared to neutral flame, but in some cases like non-ferrous alloys like copper based alloys, zinc based alloys, which are very difficult to oxidize, in those cases we'll have to use oxidizing flame. And in this case, as you can see in the figure also, the white cone, inner white cone is smaller compared to both neutral and carburizing flame, and that the heat generated temperature will be maximum in this case of flame. Okay, so next is the welding equipment. As you can see in the figure, there will be two cylinders, oxygen acetylene cylinder, and from there will be regulators to regulate the volume mass flow rate of oxygen and acetylene. Then both are taken out separately and mixed together before burning in the torch. And there are, as you can see, these small circles near the hand of the operator. These are valves to control the mass flow rate of both oxygen and acetylene. Then there is a filler rod to fill the gap between the joining metals, and the filler rod is of same material, generally same material that we are going to join, and this is called base metal. And there are other welding methods that we are going to discuss in the next slide: forward welding, backward welding. And in the acetylene cylinder, inside the acetylene cylinder, there are some absorbing material like porous material like calcium silicate and acetone. Okay, calcium silicate is a porous material inside which there will be acetone, and acetone, one of the good quality of acetone is that it can absorb 420 times of its volume of acetylene. Okay, so that will we can store more amount of acetylene in a smaller volume. But sometimes what happens, acetone may leak through the acetylene pipe. Okay, that is not desirable, that will decrease the temperature, and from we can know that acetone is leaking. This third point, there is a mistake, this should be acetone, not acetylene. If acetone leak occurs, then the purple flame will be created, and okay, flame will become a little bit purple, which is not desired. Okay, so that we can fix it by seeing if we see a purple flame. Now in the fourth point, instead of acetylene, we can also use a acetylene generator. That is, we will directly generate acetylene and will supply to the flame. Okay, that we can use instead of acetylene cylinder. And the acetylene is generated at a pressure of 100 kilopascal. That we can use instead of acetylene cylinder. Now, as I told you in one of the previous slides also, that first the acetylene is opened. Okay, while doing the welding process, first acetylene is pipe is opened. Then the acetylene will burn using the help of oxygen from the atmosphere. and obviously then in that case oxygen will be less, so the flame will be reducing or carburizing flame. Okay, when acetylene will burn with the help of oxygen from the atmosphere. In the next step, the oxygen valve will be opened, and it will be open until the intermediate flame feeder. Okay, because of the carburizing flame there will be an intermediate flame feeder because of the excess amount of acetylene present, and we will open the oxygen valve until that intermediate flame feeder will become smaller, and until it will reside with the inner white cone. Okay, until that point we'll have to increase the volume of oxygen. Then the welding torch should be held at an angle of 30 degree to 45 degree from the horizontal plane for optimum welding efficiency. Also the white cone where the temperature will be maximum, it should be at the height of 1.5 to 3 millimeter from the plate to give the proper heat. And there are two methods of welding depending upon the movement of the direction, that is direction of the torch and the filler welding rod. There is one is called forehand welding, the second one is called backhand welding. As you can see in the figure, in case of forehand welding, the tip is directed towards the direction of welding. Okay, but in case of backhand welding, the tip is directed directed opposite to the direction of welding. Okay, so in case of forehand welding, what will happen because of this change in the difference in direction is that in case of forehand welding, before the welding takes place, before the joining takes place, there will be some heat applied to the joining. Okay, before the welding occurs, there will be some preheating done to the welding. Okay, so that is helpful. And in case of backhand welding, there will be heat applied after the welding completes. So that means annealing will be done in case of backhand welding. So if the metal requires annealing, then we will go for backhand welding. If the metal requires preheating, then we will go for forehand welding. And obviously in case of backhand welding, there will be more heat will be applied because after the welding also there will be heat application. So in that case, the welding bead means the welding welding thickness, that will be more in case of backhand welding. Alright, and backhand welding, that's why it is applied to thick metals. Thick metals backhand welding is applied. If it is thin material, then we can go for forehand welding. Okay, so this is about gas welding and oxy-acetylene welding process. In the next video we will discuss about oxy-hydrogen welding process. Okay, so if you have any request or feedback to give, then you can use this number. So see you in next video.